over with you some of your homework problems. Let's take a look at an example that I gave you for homework. Let's say our blue function, or piecewise function, or lines, is our pre-image. So we start with the blue line, and then we make a scale transformation, and we get the piecewise functions, or the set of lines for the red lines. Let's try and figure out what type of scale transformation is going on here, both horizontally and vertically, and then we're going to write a function. We'll notice that with our pre-image, or our blue line, if you take a look at this point here, we have x is equal to 2. And then we make a transformation. In here, we get x is equal to 6. So we definitely stretch the graph or set of lines along the horizontal axis. So we have a horizontal stretch. So we have a horizontal stretch by a factor of 3. Also notice that with our pre-image, or blue line, the y value here is equal to 9. Our image, the y value here is equal to 3. It's easy to see that we have a vertical compression or a vertical shrink. So we have a vertical compression by a factor of 1/3. The height of the red graph is 1/3 the height of the blue graph. So we can write that in function notation. Y is equal to 1/3 f. And now again, remember, we have a horizontal stretch by a factor of 3. So we would write that f of x divided by 3. Again, remembering that the stretch factor for horizontal stretches and what we put inside the parentheses in function notation are always reciprocals. So 3 and 1/3. Okay, again, let's look at the same set of graphs, but this time we'll have the red line be the pre-image, and then we'll make a scale transformation to the blue line. So notice that for the pre-image, again, we start here, over here on the right, as x is equal to 6. And then we take that red line and we compress it. We get a value of x is equal to 2. So horizontally, we have a compression by a factor of 1/3. We started with 6, and now we're at x is equal to 2. So we have a horizontal compression by a factor of 2/6, or equal to 1/3. So that was a horizontal compression. Let's look at our y values. Initially here we were at y is equal to 3. After our scale transformation, we're at y is equal to 9. So we have a vertical stretch. We have a vertical stretch by a factor of 3. 3 times 3 is 9. Okay, so in function notation, we would write these scale transformations as y is equal to 3, that's our vertical stretch, function of 3f. x. Again, always keep in mind that the horizontal compression or stretch factor is always the reciprocal of what goes inside the parentheses in function notation. So we had a horizontal compression by a factor of 1/3. So we would write 3 times x within the parentheses. So our function would be y is equal to 3 f of 3x.